I talk a lot about physics, and necessarily that's a lot of old physics, so stuff that we've known for literally hundreds of years. However, this is about new physics. In fact, so new it isn't even built yet. So new, we don't even know whether we can build it yet. Let me tell you about the Muon collider. Also, baby bisons. Check this out. These are all the fundamental particles of the standard model. The bosons are transmitters of the different forces, while the fermions make up all the matter in the universe. Actually, everything around you, everything we know, is made up of just up and down quarks and electrons. All stuff is made out of molecules, which are just groups of atoms. All atoms are made out of protons and neutrons in the nucleus and electrons in the shell. All protons and neutrons are made out of quarks, up and down quarks in different combinations. All the other particles are actually highly unstable under normal circumstances and decay in just fractions of a single second. The only places on Earth where they exist are in high-energy cosmic radiation in our atmosphere and inside particle accelerators. And that's why, even though we have found a large number of new and interesting particles, we just couldn't build anything out of them or use them for anything. Even particle colliders, which is the only place where we can create these particles, still work just with electrons and protons. Well, until now at least. This is the muon, the electron's bigger brother. It has 200 times its mass, but almost all of its other properties are identical to the electron. So if you think just like an electron, only 200 times heavier, you're not that far off actually. So that's what a muon is. And people want to build a muon collider now. It's easy to see why muons would be better than electrons. They have 200 times the mass, so you get more collision energy, you get less energy losses because of synchrotron radiation, etc. But hang on a second, we already have colliders using protons, don't we? And those are almost 10 times heavier than muons, so what's the deal here? Well, the deal is that protons are composite particles. They're made up of quarks. Let me explain it by way of an analogy. If you think of electrons as cars, you get a certain amount of energy when you crash one. Muons are bigger cars, which means more energy. Protons aren't just bigger cars, they're more like 3 cars taped together, and when crashing, only one of those will really contribute. So, even though a muon collider might nominally run at the same energy as the LHC, the current most powerful collider, the actual collision energies would be around 10 times higher. Well, all of this sounds good, but of course there's challenges. Yeah, as we said, muons are unstable, and the biggest limitation is their short lifetime. They typically decay in 2 millionths of a second. We can increase that by about a factor of 10 through relativistic effects, but that's it. So whatever we want to do with muons, we have to do it really quickly. But it can conceivably be done. Also, as mentioned, the only way we can produce muons is in a particle collider. So we need a collider to create them and then have a second collider where they can be, well, actually collided. Sounds weird, but can conceivably also be done. Then there's of course a lot of technical problems like superconducting magnets, and the ionization cooling process, and all of that stuff still needs to be ironed out. But we haven't found an absolute showstopper to date. So currently it looks like it would be difficult, but it could be done. Should it be done, though? The real question is, of course, does the world need another particle collider? What would we get out of that? And that might be a bit of a tough sell, because what we're really looking for is new stuff, new physics that we don't already know. So nothing that we can really predict. High energy physics has become somewhat stagnant recently because we simply don't have any new results to work with. We have now found everything we expected to find. And until we find new stuff, we cannot make any meaningful progress in particle physics. The obvious drawback with this situation is, of course, that we might very well find nothing new at all. And building ever bigger and bigger colliders using the same technology will soon become too expensive and too complex. Some argue they already are. There is an argument to be made that collider experiments were instrumental for figuring out the standard model, but have not contributed significantly since, at least not in relation to their cost. So maybe a muon collider could be a path forward, or maybe not. But we should at least look into it properly. If we simply phase out our current colliders, then all of the knowledge and all of the experience we have amassed for like 80 years now will be lost. And if you look at the cost of other big infrastructure projects, $1 billion for a collider seems like a pretty decent investment when compared to a bridge to nowhere or a mile of high-speed rail. But maybe that's just me. Maybe the best way to look at the Muon collider is that it's a testbed for new technology, and as an added bonus, it might even generate interesting new data. But no one can promise that, and nobody should. Because the intended site for a muon collider is Fermilab in Illinois, where an existing collider tunnel could be used. And Fermilab adopted the bison as a mascot in 1969, when the lab director brought the first animals to the site, as a symbol for scientific research being a form of frontier. They even have a bison in the Fermilab heraldic seal. And if you want to watch some baby bisons chilling at Fermilab, you can check out the Bison Cam on site. Link in the description.